means that it has a companion. It has something that is revolving around it that is making the star wobble like this. So how do they measure this wobble motion? When we casually look at the night sky, we will not see stars oscillating. We have to carefully measure the light coming from those stars to understand this what a spectrum is. I'm sure most of you have done this experiment where you pass light through a glass prism, white light, sunlight through a glass prism. So this rainbow of colors is called the spectrum of white light. It is what white light is made of. It is a composite of all these colors. So what the glass prism does is it disperses the light. Disperse means to spread out. That is what astronomers also do. When they point their telescopes to collect light from the stars, at the back of the telescopes, they connect an instrument called spectrograph. This spectrograph will take the light which is collected by the telescope and it will split it into its component colors. And it will produce a spectrum of the star's light. Now, why the recording of a spectrum is important is because this animation will help you understand. So here this is purely an animation again. This is not real data. Just to make you understand the concept, this animation is being used. So here in the center is the star and around it is a planet. Remember that in radial velocity method, we don't see the planet. Our observation is only on the star. We cannot see the planet. For the sake of our understanding, the planet is shown here. So astronomers will point telescopes to stars and they will collect the light and the light is sent to a spectrograph. The spectrograph disperses the light and we see a spectrum like this. So the spectrum is shown at the bottom here, like this rainbow of colors. Now you can see some lines by atoms, by chemical elements that are present on the star. So look what is happening to those lines. As the star wobbles, as the star oscillates, or as the star is moving around the center of mass, the spectrum is shifting from blue to red and then again black to blue and again back to red and again back to blue like this in a cyclical manner. This phenomenon is called Doppler effect. In a source, students who are in higher secondary school would have studied this. Maybe middle school you may not have studied it, but you will study it in future. Its light will shift towards higher energies or shorter wavelengths and it will shift towards blue part. When the source is moving away from us, when the source that is emitting light is moving away from us, then its light will shift towards lower energies or it will shift towards red. So this blue shift and red shift periodically is what helps astronomers to come to the conclusion that the star is not stationary, but it is oscillating or it is wobbling. So even though they are just observing the star, by observing the light from the star and by recording its spectrum and measuring this Doppler shift, they will be able to tell that the star has a companion planet. Now, if the companion planet is very big, then the shift in light is also going to be very big. Now, how far away the planet is from the star will determine how much time it will take for the light in the spectrum to shift from blue to red and back to blue. One full cycle of shifting, the duration it takes for that will determine how far away the planet is from the star. If the planet is closer, then it's going to orbit around the center of mass in a shorter time period, which means that the wobbling time period of the star is also small. So the shift in spectral lines is also going to be of shorter duration. If the planet is far away, then the planet is going to take a lot of time to go around the center of mass of the star-planet system. So correspondingly, the wobbling of the star will also be of longer duration. So the shift in spectral lines is also going to take a longer duration. So just by measuring this Doppler effect, for the light that is coming from the star, astronomers through this radial velocity method, they can determine